From the great halls of their house, there are assembled three who hope to one day be the world's greatest driving heroes. Created from the cosmic legends of the universe comes our team captain, the Vision Bill Fisher. There's soon to be Wonder Woman, Vicky Fisher, our Captain Marvel, Net Flight trainee, Jennifer Scripchuck, and our Batman, master of tools, gadgets, and all things mechanical, our mild-mannered soon-to-be billionaire, Alan Danvers. Their mission? To fight injustice, share what is right and wrong, to get you out of your house and come out racing with them, and serve all mankind. They are the Garage Heroes and Training Team.
Welcome to the Garage Heroes and Training Podcast. I'm going to be one of the hosts for this episode. My name is Bill. Who else is hosting?
Vicky.
You are. Miss Vicky,
Yep.
We're doing part 2.
Yep.
Nik Romano was generous enough to share some more of his time, and we are going to have part 2 of our suspension, and maybe we might even get into dialing into suspension. Who knows? Last one took a long time to get to where we were. We're going to keep going, though. Nik, welcome back.
Thank you very much. Yeah, who knows? Maybe we'll get past just the fundamentals of what is a strut this time.
see, part of the joy of this is I know a little, and Vicky knows maybe a little less. She's holding up a big 0 sign on a video
I
podcast.
put suspension on.
Yes,
I've not
she does.
dialed it in.
Yes. So, you know, it's tough when the person questioning doesn't know what they're talking about, but I'm going to try.
Well, so we spent so much time on the strut last time. What I really want to talk about is tires. Because tires are where all the magic happens. But
Yes.
in order to understand what's going on with the tire, you have to first understand what's going on with the suspension, because the two interact with each other so strongly.
That's kind of the
Mhm.
point of the suspension, right?
That is exactly the point. Yes.
Otherwise, it'd be the Fred Flintstone mobile, right?
Right. Yeah. Well, or you'd be a go-kart.
Yeah. Oh, a go-kart. Yeah.
But interestingly, go-karts do have suspension. It's just not springs or torsion bars or anything along those lines. It's the chassis itself flexes, and also the tire. The tire flex is part of the suspension, and even in a car, chassis flex. Less so now than they did 15, 20, 30 years ago, but they still do.
Yes, indeed. So on our first part of this, which was episode 430, which is a few back for anybody who wants to know where we started with, we covered McPherson strut a lot. And I think we were trying to say it has advantages in that it's cheap and it's simple, but it had disadvantages in that it doesn't tend to improve your handling as much as perhaps other choices that we could use.
Right. So I'm without diving back into struts.
Yes.
The basic downside is as the suspension moves up and down, at best, it just moves straight up and down. And so the tire is not going to have any advantageous geometry characteristics. It's not going to lean itself in towards the center of the car to counteract the body roll of the car. And that's really was one of two main components. There's what is the geometry, where does the tire end up as it travels, and where is your roll center. And for the most part, you're not really changing the actual geometry of the suspension. There are roll center adjusters, but that's kind of beyond the scope of what we're talking about. So really the big part is, what is your alignment while the car is actually in motion versus what did you set it to in the garage?
And you can semi-model that by loading the car or unloading the car and seeing how the camber changes.
Yeah, absolutely. So the first thing you'll have to do, this is kind of a complicated, well, it's not complicated, it's just time consuming. So you have the car on the ground, you take a measurement from the wheel hub to the fender to figure out where your static position is. Then you put the car in the air, you take the springs out, and then you put the suspension back together without the springs. You put a jack underneath the suspension, you lift it up so that you match that measurement so you know where static is, and then you start moving it up and down from there and see exactly how it behaves. And the important things you're going to look at here really are toe and camber.
Okay.
So toe would also be known as bump steer. So does this? Oh, by the way, this is in the front and the back.
Why did no one ever tell me that?
Probably because they weren't aware.
I've been looking for bump steer forever, and I understand toe. Okay, fine, whatever.
Well, if you understand toe, you understand bump steer. All it is what is the toe as the suspension travels. So when you compress, does it turn in? Does it toe in? Does it toe out? Or does it stay straight? Does it stay straight? And the general consensus is you don't want bump steer. Although that's not entirely true all the time. There could be some benefits to a certain amount of bump steer as long as it's working in the correct direction, the correct amount. Let me give you a quick example. So if there's zero bump steer whatsoever, and you lean the car into a turn. So let's say we're going into a left turn. The right side suspension is going to compress. The left side suspension is going to rebound. So they're going to be moving in opposite directions. So let's say the car tows in under compression. That means the right side, which is compressing, is going to tow in. So it's going to turn to the left. The left side, which is rebound, is going to tow out. So
it sounds like it helps me.
Going to turn right. It does sound like it helps you. And it does to an extent. If both are working in perfect harmony and it's not too much and it's not and it's a smooth track, and that's kind of the kicker there. If it's a smooth track, you're probably fine. It actually can feel like you have a quicker steering ratio. This is actually an experiment I did many years ago where we 100% removed all bump steer from a car, drove it, and it felt like we put a truck's steering rack in it. That's a little bit of an exaggeration, but you could feel the difference in the amount of steering input you needed to give. And then when we put a little bit of bump steer back in, it felt more direct, more responsive. So the real problem is if there are bumps, because then, like, let's say you're going in a straight line and you go over a bump, which is unavoidable. Now the steering is towing in and out wildly without you moving the steering wheel. So it can make the car really darty and unpredictable.
So this is not the car you want to take to Sonoma.
It is no, no, it is not.
Okay. All right. Just for those playing the home game who aren't aware, Sonoma is an old World War II landing strip, I believe, and it's got, from what I hear, some amazing, spectacular bumps and dips on the track. So,
are you talking about Sebring?
Sebring? Yes, I'm talking about Sebring. Did I say Sonoma?
Yes.
Oh,
you said Sonoma. Now Sonoma's got some pretty big bumps too. There was
I meant
they did a test with a Formula One car there a couple of years ago, and the driver of the Formula One car could not fathom how rough the track was. And Sonoma feels pretty good to me, but I guess that just goes to show what a Formula One track is actually like.
Yeah. I don't think we're quite spoiled. So Miss Vicky,
yes,
you got that? You're good with tow? You know what tow is?
I am going to have to re-listen to this entire series of podcasts, but
So tow in, if you look at the front, you're looking at the front of the car. If it's towed in, your tires point, they're like pigeon. Is that pigeon? Pigeon toe.
Pigeon.
Okay.
Pigeon.
And toe out is duck toes.
Okay.
So they're saying that as the tire goes up and down in the suspension, does it move turning in or out?
Okay. My thing was the understanding about taking the springs off to find static. I mean,
we'll go back.
What are you doing?
You want me to try? How about I try and see if I understand, and then Nick will correct me because I'll be wrong. So you take the coil over, you take it apart, you take the spring off, and then you put it back together. So now you don't have the spring fighting you, so you can run the shock through its shock may not be the right word. Sorry, people. Strut, whatever, up and down through its range of motion, and you can see how your tires move. How'd I do?
That's pretty good. So Vicky, the car's got to be up in the air for this. So you've got it up on jack stands, and then with the spring out, you can just grab the suspension and just move it up and down freely. There's nothing. The spring isn't preventing you from moving it.
Right.
So that enables you to run it through its entire range of motion, and then measure the difference in your alignment as it moves up and down.
Okay. All right.
So that's really, and when I was talking about static, before you lift the car up, you got to know where is it normally. Like if it's just rolling down the road and down a straight line, what ride height is it at? That way you know where your 0 point is. And then you can move it up and down from there to take measurements on exactly how it's moving.
And is that just to take the range in? Is that what you were saying?
Yeah, so you can accomplish a couple things there. You can look at your toe, see if you have bump steer. You can look at your camber gain to see if your suspension is working for you or against you. You can also, this is actually a pretty important thing that a lot of people forget about, is if you put the wheel and tire back on, you can figure out what hits what first. So if you push too far, like if you bottom the car out, does the tire touch the inside of the fender? Or does the bump stop hit first? It's important to know.
Okay.
We found that out the hard way on the Miata.
What did you hit first?
It was not the bump stop. Nope, not the bump stop. That's
Bump stops are your friend if they're being used correctly.
Mhm.
It's better to hit a bump stop than to hit something solid.
Yes.
But you don't want to be on the bump stop all the time.
Nope. And you don't want to be what we were on, so we fixed that. But that was fine. We had a shock that had left the building, but we picked the car up that way, so we didn't know it was different because that was what it always was. So yeah, that was bad. Anyway, okay, distractions. That's me.
All right, so let me put a bow on this. So you're measuring your bump steer and hopefully correcting it if you have the ability to do that with the hardware you've got on the tie rods. The basic idea is very little to none. Bump steer is mostly bad. And then you're looking at your camber gain. And this is where the strut versus the dual arm setup really comes into play. The strut will have the tire go straight up and down. And whereas the dual arm will have the tire come up and also lean in at the top. So go negative camber. And the reason, go ahead.
So it's an arc.
It's an arc, exactly.
Okay.
And the reason that matters is because when you go into a corner, the whole car leans over. And so if the tire just does nothing, if it just follows the body of the car, then you're just going to be using the outside edge of the tire. Whereas if the dual arm suspension is letting it lean in towards negative camber, then that will counteract the body roll and hopefully your tire is more or less straight up and down. Does that part make sense?
Yeah.
That's a lie.
You know what? The thing is I'm usually, instead of having it explained to me, it's better if it's performed before me.
I'll go show you this one. I understand this one.
Yeah.
We'll have to do a video podcast.
We might.
Yes.
Everybody can see my hand motions that I can't stop myself from doing.
I know.
Yeah.
Exactly. We just had an episode on hand gestures, but these are the helpful ones when you're driving, not the normal ones that I use. But anyway.
All right.
Okay.
So that's the benefit of the dual arm, is it just lets your tire be in better contact with the ground. And when we're talking about where do you even set your camber? How do you know what to set it to? Well, generally speaking, a car with a strut will need a whole lot more camber than a car with a dual arm, because you have to counteract.
It doesn't gain.
Yeah. You have to counteract all the body roll of the car. So then if you follow that logic, the softer the car is, the more the body's going to roll, the more you'll have to put negative camber in to counteract that. And the stiffer the car is, the less you'll probably need.
I got that. I'm good with that.
Yeah. But you don't really need to know any of that, because all you really need to know is, what does your tire want? And the way you can figure that out is with a tire pyrometer. So that is a little thermometer with a little metal pin on the end, and you actually stab it into the tread of the tire. It's only a couple mil long, but you physically stab it into the tread of the tire, so you get a little bit deeper temperature reading. And you take a reading 3 times across the surface of the tire, the inside edge, the middle, and the outside edge of the tread. And you look at the differences in those numbers, and that will tell you what this tire wants to have, both with pressure and with camber.
And you got to do that really fast because your tires cool down really quick. And you want to do it as quickly as you can from coming off the track onto pit lane. Like, don't just dilly-dally around.
Yeah, you have to come in hot. You have to make sure you or whoever your driver is comes in really hot. But also, you want to do it consistently. So if they're really hot one lap and a little bit slower the next lap, that data is not so useful.
Okay.
So even if they are a little bit slow coming in, if they can do the same thing every time, you can still have some data that you can work with.
Right.
So generally speaking, and jury's out a little bit, you get a different report from different people about what exactly they want to see. But generally speaking, you're looking for about a 15 to 20, maybe even 25 degree difference from the inside to the outside of the tire. You want the inside to be hotter than the outside.
Okay.
I listened to a podcast with a guy who looks just like you, and he told me the reason why you want that.
And what was that reason?
Because the tire has some camber, so when you're going straight, the inside is touching harder than the outside, so it should be warmer.
Yeah, that's exactly right.
Okay.
See, I listen to my guests.
Excellent. Yeah, so it's when you're in the middle of a turn, you won't have that split, that 15 or 20 degree split. It'll be more or less even. But then because you have straightaways, it biases it more towards the inside. And then you also want to make sure that you're not overinflated in the center or overly hot in the center or overly cold in the center, and that can tell you if your pressure is good.
Mm-hmm.
And all this really comes down to, what do these tires want? Because that's where your mechanical grip is coming from. It's entirely the interface between the tread of the tire and the pavement that you're driving on. And every single thing that you do to set up the suspension is adjusting how much pressure you're putting on these tires independently of each other.
So tire temperature, I get the spread. I even understand why you want inside versus outside to be a little different. I'm cool with that. How do I know? Because I don't work for Michelin, right? I just look like the guy, but I don't work for Michelin. How do I know what temperature to be aiming at? Like, am I too hot, too cold, or am I just right? Like, is there a rule of thumb that we could use, or is it vary from tire to tire or tire manufacturer to tire manufacturer? I just that part's always been puzzling.
Yeah, so it does vary a little bit between tires. If we're talking about race tires, or even like 200 treadwear tires, anything that gets used as a race tire, the manufacturers are actually usually pretty good about giving you that info and telling you what they want. But generally speaking, it's somewhere on the order of 180 to 230 degrees Fahrenheit.
Mm-hmm. Yep. We had Danny on from Hankook, and he told us exactly what temperature for the RS4. So I know that,
Which
but
was
I
what?
have, I'm looking it up right now as we speak. It was hotter than that, I think. But,
oh, really?
Yeah. But I will get it for you and tell you. But I was wondering, because we're going to try some new tires, because we've got some other tires that we're going to be using for different series. And I was wondering if aim at that temperature, or, how to know what to do. So I guess I could experiment and find out. But
yeah, well, you generally don't have to worry too much about it unless you are too cold.
okay.
If you're too cold, then the tire will never behave the way you want, and then the car is not going to create as much grip as it would normally, so it's not going to lean as hard, so your temperature numbers are not going to be correct, and it just kind of muddies the waters. Now, too hot will happen if you overdrive the car, if you're sliding it around, if you're getting a bunch of understeer and you're just being a bit ham-fisted. But as long as you're not doing that and you are getting it up to temperature, then you should be good. You're probably not going to overheat it just by driving fast. By driving well.
Yes. Or playing Drifto. Yeah.
Right.
Yeah. I know somebody on this podcast who can do that. It's not Vicky and I, but anyway. Okay. So
we've covered. Go ahead.
So we got the tire temperature, and we've got the tire temperature spread. And then you want to have the same tire temperature kind of readings across all four tires?
They're almost never going to be exactly the same. But yeah, if you can get them close, and that's great. Like in your fit, the rears are never going to be as hot as the fronts, because they're just not doing hardly as much work.
So you have to use your brain and think about, like, if you're at Lime Rock, your right side tires are probably never going to be the same as your left side tires. Just
correct.
Nature of the car. And you got to think about the nature of your car that has an impact on this. Because like you said, the fit, front, fine, rears, not so much. So.
But if all else is equal, there are ways to adjust where that load and therefore that temperature goes. If you have a perfectly balanced car, and let's say it is capable of heating all four exactly the same, but it isn't, you can move that load around with your springs and your bars.
I think last time you were on, we were using the E46 as an example car.
I think you're right. Yes.
And that would be kind of a more or less, each four tires should be close, theoretically.
Yeah, and there's still more weight in the front of that car than there is in the back, but it's not by a huge margin. And you're asking all four tires to actually do work, unlike in the fit, where you're really only asking the front tires to do work and the rears are just along for the ride.
Got to keep the back up off the ground,
Yeah, yeah. but even in an FF, in the fit, so if you follow the same logic that we talked about before, if the rears are not really being used, that would imply that the fronts are doing all the work and you're probably getting a fair amount of understeer. So if we just follow the same pattern, or the same path that we had talked about in the last episode, where you stiffen the rear springs or soften the front springs.
The way that I understand it is you want to kind of use either spring stiffness or a roll bar or anti-sway bar or whatever. Sway bar, depends on what country you're from, apparently, to augment the weight distribution.
Yes, so that's going to create your dynamic weight distribution rather than your static weight distribution.
Right.
So when you compress on a spring, it pushes back, equal and opposite, right?
Right.
And in a car, it just so happens that it goes diagonally. So when you lean in the car into a turn, let's say a left turn again, the right front is going to push down on the left rear. And that's the cross that people talk about. And then the right rear is going to push down on the left front.
Right.
So if you are getting understeer, for instance, if you increase the rear spring rate, it's going to push harder onto the left front, increasing the amount of work done there and loosening up the car, freeing up the car.
Right. And then you can use those adjustments to get them closer to balanced.
Yeah. And if you're able to get the rears to do more of the job, they're going to heat up more. And especially, if you free up the rear end and starts to slide around more, it's probably going to get hotter.
So for the cars, like the front wheel drive cars that have a predominant weight bias towards the front, because the driver's there, the engine's there, the suspension's there, everything's there. There's no drivetrain to the back. There's no diff in the back. There's no, even the gas tanks are sometimes towards the front. You're going to want to try to, you've got 4 tires, you might as well use them, right?
Exactly. Yeah. Interestingly, on a front drive car, the ideal weight balance is something on the order of 60% front, because it's a weird situation where adding weight adds inertia, so which will create understeer in the front end, but adding weight also creates grip because it's pushing the tires harder into the ground. So it's a kind of a strange catch-22. You need the weight to create grip, but the weight also takes grip away once you're trying to get the car to actually change direction.
Okay.
Okay. It ends up being something like 60%, 62, somewhere around there.
Okay. Well, it's kind of one of those things, unless you're willing to add weight, there's just not a lot you can do. It's kind of the car you have is the weight distribution that you have. So
yeah, and that's where the suspension tuning comes into play. You change the springs, change the bars. And by the way, the bars are springs. You can think of them in the same way. The only difference between a bar and a spring is that the spring is in effect whether you're accelerating, decelerating, or turning, whereas the bar is really only in effect when you're turning. There's some crossover. There's a little bit of bleed over, but mostly when you're turning. The further the car's leaned over, the more that spring is in effect. Okay.
So I don't know that I want to ask this question, but I want to ask this question, and I'm not sure. Are we how sometimes, you just veer off to the left. If I throw aero onto the car, what have I done?
That's an excellent question. So
I don't know if it's the right question now, though. That's my question.
Well, no, it's all right. So aero creates aerodynamic grip as opposed to mechanical grip. Before I make it complicated, let's stick with the simple version, which is the harder you press down on one axle of the car, the more spring you're going to need to counteract that. So if you don't have a splitter, but you put a wing on the car, it's going to push harder down on the rear end, especially the faster you go. And if you do nothing else, the car will understeer because you've added all this grip to the rear and you've done nothing for the front. So by increasing the rear springs, and bar doesn't do anything here because the bar will just sort of freewheel, so to speak. It will, the wing will push the rear end down and the bar will just move out of the way. It won't do anything. So it has to be the spring. So if the wing on the back is pushing the car harder into the ground, you'll need additional rear spring rate to counteract that and then transfer that load to the front so that you balance the car back out.
So is that why sometimes you want a wing on a front wheel drive car, which has never made any sense to me whatsoever?
Yeah. So what a wing can do is it can allow you to adjust the car for different scenarios, because on a track, not every corner is the same speed. So in a front wheel drive car, most often you're putting really big, heavy rear springs and a really big, heavy rear bar in because you're trying desperately to get the car to rotate because it just wants to understeer naturally.
Right.
Which is all well and good on a low speed corner. But then as you get to a high speed corner, let's say you're trying to do 100 miles per hour through Riverside at Buttonwillow, now you've got a death machine.
Yeah. I was going to say, I'm making diamonds right about now.
Yeah, exactly. So on a front wheel drive car, adding a wing allows you to fine tune for the different speeds of turns, because the wing's not really going to do anything on a 45 mile per hour turn.
Right.
So your really oversteer bias suspension setup will allow you to rotate your front wheel drive car, and the wing's not playing into it. But then as you get faster, 80, 90, 100 mile per hour turns, now the wing is there pushing the rear end down and giving you that extra stability.
That sounds lovely.
It is very lovely when it's all set up correctly.
Oh, there's those details again. We're gonna get there. We're gonna get the setup someday. Okay.
Well, here's a fun little nugget that has very little to do with what we're talking about. It's just kind of fun to think about. So in the late 60s, when wings and aerodynamics were first really, well, I should say wings and downforce were first really being experimented with, there was a somewhat common design where rather than the wing being attached to the chassis and pushing the chassis down, the wings were attached to the hubs. So it didn't push the chassis down, it just pushed the wheels straight down into the ground. Kind of cool. Because it doesn't affect where when
the wing goes around and round and round with the hub, that's a problem.
It gets really exciting when the car launches itself up in the air.
Yeah.
And to be perfectly honest with you, I have no idea why we don't do that anymore, because it makes a lot of sense to me, but there's probably some engineering reason why it's not actually great, but that's beyond my scope.
Lever arm, maybe?
Could be. Yeah, I'm not really sure. But it's fun. It's fun if you go to a motorsports museum, you can see cars like that, like Can-Am cars or early Grand Prix cars. Not early, but late 60s Grand Prix cars where the wing goes straight to the hub.
I thought for sure you were going Chaparral.
Well, I'd have to look at the photo. I'm not sure if that one has it.
I'm not sure. Do you know what the Chaparral is, Miss Vicky?
No, I do not.
That's a no. Do you want to do it, Nick, or do you want?
So the Chaparral is basically a trapezoid with wheels.
Okay.
A trapezoid with wheels and a 900 horsepower plus V8.
And a
Interesting.
fan.
And a fan.
Yeah.
Oh, you're talking specifically about what was that? The Chaparral 2. What was that called?
I don't know. I just play it on video games. It's pretty cool.
Yeah. Well, so Chaparral made a couple of different cars, but the one you're talking about, so Vicky, it had, in addition to its engine, it had a second engine. I think it was a 2-stroke actually. And all that engine did was ran a big fan, or I think it was 2 fans maybe. And those fans sucked air out from underneath the car to literally suck the car to the ground.
Oh, wow.
So it created downforce at any speed instead of just at high speed. So that would be an exception to the rule of our fit example, where the wing is only working at high speed. This one works at any speed, including 0 miles per hour.
Our cars don't suck that way, but they suck.
And
so
just
it's basically
like
suck into the ground.
They're huge.
Yeah, absolutely. And
You're talking about the wing, right? Or the car? Chaparral car.
Let's see.
Because I'm looking at a Chaparral official, and I'm looking at this massive wing on the top of it.
Some of them had big wings.
2J. Vicky, look up the Chaparral 2J.
Okay. All right, I see it. Hold on.
Look at the back end of that thing.
Images. Oh, wow. I see the fans. What the heck?
It looks like it's a land speeder from the original Star Wars movies.
And you said this was in the 60s?
Yeah, this looks like mid-late 60s. I couldn't tell you the exact year. Oh, I guess I could look it up, but maybe 1970.
They got it through by saying it was to cool the engines.
Oh, sure it was.
and how did this thing perform?
It was dominating.
It was outlawed very soon. very quickly after it was.
I think it made one race. I think before it got outlawed, it was not very long at all.
Yeah, it's kind of cool looking at the photo. You can see some of the details, like the car is basically touching the ground. I believe that's a rubber strip that goes around the outside to seal it to the ground. So as the fans were sucking the air out, it actually just really push it down in there.
They call it the vacuum car.
Exactly. Yeah, or the sucker car.
That's right. Everybody who wasn't driving one was a sucker.
Exactly.
In fact, it was so fast that the FIA officials banned the 2J at the end of the 1970 Can-Am season.
Oh, it made it through a season. I didn't know it made it that long. Oh, wow. Check that out. Who knows?
Because the sliding polycarbonate skirts were said to have violated the movable aerodynamics device ban. thus ending the car's career.
Yep.
Interesting.
But it lives on in Gran Turismo.
Okay. Very nice. Okay.
All right,
So we
we're
were
going
talking about
back.
aero, about
Mhm.
normal aero, not ridiculous sucker fan aero. So we talked about the rear wing on a front wheel drive car, which actually, when you put it in the terms we talked about, it's pretty simple and makes a lot of sense. It can
Mhm.
make a big difference in the car and really let you set up the suspension the way you want.
But if I do that, do I need to pretend I've got a front wheel drive car and I go to put a wing on it, and the front wheel drive car, let's assume it's set up the way it should be. If I put aero on the back, do I need to change my rear springs?
It depends on how the car was behaving before.
Okay.
So generally speaking, cars will be more oversteer biased at higher speeds.
Or oversteer. Okay.
And there could be a lot of reasons for that. Let's stick with a simple one, which is the shape of a car is a wing generally. So the faster you go, the more lift it generates. And a lot of what we do, what we talk about downforce, is actually lift reduction.
Right.
So reducing lift and creating downforce are effectively the same thing. They're getting the car to stick harder into the ground at high speed.
Okay.
But yeah, the shape of a car, if you imagine the profile of an airplane wing and the shape of a car, especially a coupe, it's kind of the same.
Yeah.
So they're creating lift as they go. So it depends on how the car drives. If you are super duper happy with how the car behaves at low speed, you've got plenty of rotation, and then you get to a high speed turn, like I mentioned, Riverside at Button Willow, and you're able to stay 100% flat the entire way through the turn, you're probably not going to really benefit much from a wing. In fact, it might slow you down due to the drag.
Mm-hmm.
But if you're in a situation where the car is great on low speed turns, but it's really unstable at high speed turns, you're having to pedal quite a bit, you're having to not go as fast as you want to because the rear end's trying to get away from you. Well, yeah, then a wing is definitely going to benefit you. And then to take that one step more complicated, if the car feels great at high speed, but it's an understeering pig at low speed, then a wing gives you the opportunity to then adjust your suspension to better suit the low speed.
Because it'll take care of the high speed for you.
Right. So then you can just dramatically bias the car more towards oversteer and get the benefits of that at low speed, and the wing takes away the drawbacks at high speed.
I think Miss Vicky should be excited, but I think she's confused because I think this is what she needs.
Oh, does the Fit need this?
No, the Civic does, because I think
so
she's
Vicky,
uncomfortable at high speed.
Vicky, describe to me what you're feeling in the Civic. Low speed turns versus high speed turns. Are they different?
Would that happen to be also maybe because I have 2 sway bars on my car?
Well, yes.
Which I just realized that.
It's part of it. So 2 sway bars on the front or 2 sway bars on the back?
We have a sway bar on the front and on the back.
Oh, sorry. I thought you meant you were doubling them up, because I have seen that done in Lucky Dog, Champ Car, that sort of thing.
No. Sometimes I just feel like going around that I personally have never been comfortable with my tires ever.
Well, talk to me more about that. So when you say you're not comfortable, why not? What happens?
I always feel like the tires are going to give out underneath of me so easy.
And
give slide.
Out, meaning sliding, or?
Yeah, which means that I'm going to lose traction. So going in hot in a turn from the down straightaway, I just have a hard time having faith in my tires. And maybe that's because I just don't have enough track time with them in general.
Do you find that it's easier to push harder at the slower turns, or is it about the same everywhere?
Oh, definitely easier on the slower turns. I always just have a hard time, mostly on the straightaway. I don't have a problem with any of the other turns, only because I feel like I have more control. I always feel like, well, I'm only going in second, third gear, depending on what part of the tracks that I am. On those back straightaways, I'm kind of running fourth, but I'm working up onto my speeds, obviously, to get higher. But it's always that straightaway, coming down the straightaway and just kind of like hitting that, that first turn after the straightaway. I have a hard time with confidence level on that.
Mm-hmm. Well, confidence level is definitely part of it, but that confidence or the lack of confidence could be coming from an unstable car. It's very possible the car is not as stable at high speed, and that's where you're getting that feeling from.
Mm-hmm.
So if you were to add a wing to that car, you probably would feel a lot more comfortable because the rear end would be so planted. And it may be that you put a wing on, and you make a bunch of downforce, and that will then allow you to start pushing harder and harder and harder.
Mm-hmm.
And then once you start pushing harder, you might go, well, I'm definitely going faster, but now the car feels like it's understeering. And then you might take some of that wing away. And who knows? It may be that the car is actually great the way it is. You just weren't comfortable yet. And once you gain that comfort from the extra downforce, you might take it back away.
Right. I agree with that. I agree.
It's interesting in that regard. Tuning the car, whether it's mechanical grip or aerodynamic grip, can also be a function of tuning the driver. It can help a driver in their development process if it exposes them to more traction, the ability to push harder, the ability to go faster, and then also recognizing those changes and feeling, when I put the wing on the car, yes, I do definitely feel how this has changed the behavior of the car in these areas of the track. And the more specific you can get, the better.
Mm-hmm.
Yeah.
So when I was driving my Miata at first, I was becoming way more comfortable with the Miata because I always felt like I was sitting more in the center of the car. And because it felt like the car was strapped onto me. I felt like there was a good center of balance. Then I moved over into the E46, or I think it was the E36 at the time that we had it. And there's something about the weight and again, the center of gravity that was in the car that made me feel very, very comfortable. Now, when I was driving, say, the truck, I always felt like the back end was super light. So all of my manipulation had to be done, like it was more able to be manipulated because the back end was lighter than the front end. And then the same thing with the Honda is because everything and all the weight is in the front end and none is on the back end. So I always feel like the car doesn't feel balanced for me, if that makes any sense. So I always feel like those back tires are just going to give way out from under me.
That makes a ton of sense.
And it's just like, maybe it's just like I said, maybe it's just a mental thing for me, but it doesn't feel balanced. It feels like everything that I have to do and the weight of both of those last two vehicles that I mentioned was always in the front, and the back was always able to be slid or manipulated, or like I just don't have faith in that back end. So it's just weird.
It is a mental thing as a result of the physical thing. Because you're totally right. The rear end of a truck or of a front wheel drive car has no weight on it whatsoever. And generally speaking, on a front wheel drive car, you'll have such a stiff setup on the back because you're almost trying to eliminate the back from the equation. You're trying to make sure the front does all the work. But
right.
the downside of that is that it can be really, really skittish and really sensitive to transfers of weight. So if you're in the middle of a turn and you lift off the gas, that let's call it a well set up front wheel drive car, the rear end is going to want to get away from you, probably much more aggressively than a rear wheel drive car. And so if you have a front wheel drive race car, your setup for qualifying or a time attack car might be very different than your setup for a race car. Because in the race car, stability is much more important. You need to be able to drive the car fast, lap after lap after lap, and not be caught out by making a small mistake, or maybe the person in front of you made a mistake and you had to lift off the gas. Well, now you're spinning out and it wasn't even your fault. So you will need a little bit more of a balanced setup there. Whereas if it's a time attack car and all that matters is your peak speed, that car might be much more difficult to drive for that reason, because any little adjustment you have to make, if you don't have it the line perfect or the speed perfect, might result in a big loss of grip in a big slide. But the benefit in the front wheel drive, or I should say what you can do as a driver to get around all that, is just keep your foot down. If the rear end slides, just win it out, power out.
Yeah, and that's what I do.
Yeah. Now the truck, on the other hand, rear wheel drive, that's almost a worse situation, because you don't really have any benefit, any way to get yourself out of it. It's just light in the back end, and the back end has to do a bunch of work anytime you hit the gas.
And it had drum brakes.
And
geez.
and it was a locked diff, and it was a locked rear diff. A welded diff. So
there's a lot going on there.
Yeah, it was fun. But I think doing this experiment with you, Miss Vicky, could be good, because part of the, and it's a problem, but it's not your problem. It's, you just don't know how to say it. Is part of it is I don't know what you mean, and you don't know what the feelings are. So if we get it to the point where we do these experiments with the, maybe with adding and subtracting arrow and putting a splitter and taking a splitter away, you can feel what the difference is, and then you'll know what the word is.
Well, I'm going to be very excited to, after this pit race, really focus on the feeling of the car before the splitter and the wing get on, and be able to, after pit race,
We're going to go test
which is next weekend, is to remove the front sway bar and feel what the difference of all those components are going to be from what I had before.
And then we'll do the arrow stuff on top, and then you'll be able to say what all these little differences mean.
Right. At least I'll have a base to start with.
Well, we've solved her problem.
That can be really valuable, to just spend the time to add parts, take parts away, change the setup, and just feel it and do one thing at a time. So you can be sure that you know, oh, that's what it feels like without a front bar. That's what it feels like when you add the rear wing.
Right.
You know what would be even better? Fast sideways east.
I'm trying.
I know.
I'm trying so hard.
Yeah.
We'll get you. Don't worry. Okay. All right. I think I digressed onto arrow for a little bit, but I think it might have been valuable.
That was a fun thing to talk about.
So going back to the tires, we've got the tires. Let's assume we've dialed in this. Well, should we assume we dialed into suspension to get the tires? How do we dial into suspension to get the tires the way we want them?
So don't worry too much about like the exact temperatures you're seeing in terms of the suspension balance. That's more of a feel thing. So the numbers we're seeing on the tires, the temperatures on the tires, that's going to tell you if your alignment is good, if your tire pressures are good and your camber is where it's supposed to be. And that's how you know you're getting as much out of the tires as you possibly can. Was my camber correct? Am I getting the tires to the temperature they want to be at? And are the pressures correct? Once you've got those down, then you can start looking into, all right, now what does the car actually feel like? Now that I know I'm getting as much grip out of this tire as I can, where can I put that grip where it's going to be the most useful?
Okay. So how do I physically, like, is there a sequence of order? Do I do tire pressure, then camber, then caster, then toe, or?
Well, you can take a swing at it before you do any testing.
Sure.
Like there are some assumptions, some educated guesses you can put into the car. Like if you've got a fit, which is a front strut, front wheel drive car, and a rear, what is it, trailing arm?
I think it's they call it something else, like a U. I forgot what they called it. It looks like a trailing arm, but it's one piece all the way across.
Oh, it's a twist beam.
Yes.
Okay, so what we know is that you probably can't change the camber on the twist beam, and you probably don't really need any camber anyway because there's no weight back there. So it's really the front we care about. In a strut, you're going to want like between 3.5 and 4.5 degrees of camber, probably. It's going to depend a little bit on the tire you've got and a little bit on how stiff your springs are and all that sort of thing. But somewhere in that range is probably where it's going to be happiest. So I would start there, maybe start at 4 degrees. And that way you're not trying to figure out the difference between 2 degrees and 4.5 degrees while you're at the track. At least you're close. And then if you look at the number, you say, oh, okay, well, it's close, but it's only 5 degrees split. So then we need a little bit more. So then you go from 4 to 4.3 or whatever it is. So it's just, then you make this fine adjustments.
Right. And then the same, there's like a rule of thumb for most cars out there, like a BMW E46 or whatever, you can do that, or Miata, same thing. You just go to what the center point is for what people are racing and then, adjust from there.
Yeah, exactly. And the BMWs are also struts, so they're going to be about the same as the fit in the front end. Miata is a dual arm, so it's going to be more like 3.5, 3.2, something like that.
Lower. Okay.
Yeah.
All right. And then, so we've got the tire. Does it matter? We're kind of focused on tires, I guess. Does it matter what kind of tires? Because I know that some of our listeners do 200 tread wears. Some of our listeners do R comps, I believe they're called. We've never done them. And some of them will do like a true racing slick. Does that matter?
Well, it matters because it's going to change the way that the car drives, but the process is the same.
Okay.
A tire is 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 a tire. You take the same measurements, you make the same adjustments, and as long as whatever tire you've got on that car is happy, and it's telling you it's happy with the numbers, then you're good. It's not like you have to dramatically change the way you approach it with a different type of tire.
Okay, so the logic follows. Okay, all right, that's good. So I only have to learn one thing now. I just have to listen to this podcast about 6 times.
Exactly.
And then take notes and then call you again and say, I don't understand. Okay. All right. So we've got that. So now let's assume we've got our tires to where the tires say they're happy, front and back, right? And the car, does that mean the car handles well? Miss Vicky,
Yeah.
I have a question for you.
What is that?
Well, you know how we have the One Lap of America coming up?
Yeah. I'm so excited.
Yeah, be even more exciting if you get to go, but we'll get you there in a year or two. Tough to get away for a week, both of us.
Yes.
So I have an idea.
Mm-hmm.
I'm thinking of hooking up the Sentinel system in the car we take.
Really?
Because then you could watch us. You could see Tim drive well and me drive poorly.
I think that's kind of a cool idea.
Mm-hmm.
I really do. So, I mean, how would I do that?
Well, I mean, with the Sentinel, you throw it up on the tube of views on our channel, and you could watch remotely. And if we wanted to, we could do it as we're driving between the tracks. But we'll definitely do it on the tracks. You think that would be fun?
I think that would be a really cool idea.
The only thing that worries me is if we do it with the telemetry. You might call us up and tell us that we need to go faster than 55 when we're on the track. So,
well, how does it work?
Well, we have the little aim telemetry in the car, and then the Sentinel system has either 2 or 3 cameras, and then it puts the 2 together, so you get all the telemetry and all the car data, and makes that part of the video, and then it puts it onto our YouTube channel, and then you could watch it, or anybody could watch it. I don't know why they would watch us, but they could.
That sounds like a really cool idea.
Yeah, it might be fun.
Might be fun.
You think you want to see some of the debacle? I mean, some of the devastating driving that we do.
I think I'd like to see you on one of the tracks at Road Atlanta,
well,
or at One Lap America, for sure.
Well, so we could do that for each of the tracks, and if we want to, we could do even a remote video while we're sitting in the car driving between tracks, eating fried chicken, making fun of each other, whatever.
Okay.
I have a feeling our food is going to be let's go with not 5-star, shall we say, for this entire week. So, but you think that would be fun? You'd want to watch that a little bit?
I think I would. Really
Okay.
would.
All right. I guess I have a new project. We're putting it in the new One Lap car
I like that idea.
and streaming.
All right.
Right. You know what I think? I think our listeners could get some value out of this too, because what they do is they go to our YouTube channel, they watch these videos that we put up, and like around sleep time when they're trying to go to bed, and they'll definitely fall asleep. It won't be any problem. It'd be like a lullaby.
They can also write in suggestions in the comments section. Yeah. Please comment.
Yes. Excuse me, Bill, the track went to the left, yet you turned the wheel to the right. Could you please explain? And I will come back with a reply saying, it's a very advanced concept. I'm not sure you're up to it. Otherwise known as we haven't finished putting our sim together and I didn't know which way the track went. But anyway, I think that's going to be a plan, my dear.
I think it's good.
All right, very well. One Lap of America, Sentinel. Made for each other. Let's assume we've got our tires to where the tires say they're happy, front and back, right? And the car, does that mean the car handles well? Or
no, that means you have the maximum amount of mechanical grip being utilized, but it's not necessarily in the right place.
Mm-hmm. And that's where you get into a little bit understeer, oversteer, or driver preference, right?
Right. Yeah. So if you've got all your mechanical grip, but the car is an oversteery nightmare, then you have to move some of that grip from the front to the back.
And move it from the front to the back. Okay, but you don't you don't want to do that too much because you can't ever move 100%, right?
Well, no, you can never move 100% unless.
But like, say, maybe I phrased that wrong. So
Yeah.
let's say you have, let's call it 50 pounds of grip in the front. I can't move 50 pounds to the back without giving up more than 50 pounds in the front.
Well, then you'd be doing a wheelie.
Yeah. Well, I've tried that sometimes. It never works. I pull on that steering wheel. The
It's
tires
really
never
hard to steer when the fronts aren't touching the ground.
No, but I know. But you can't get it. You can't. Let's say you have 2,000 pounds of grip. If I move some from the front to the back, I no longer have 2,000. I have less.
Correct. You're not making grip from nowhere. You're taking grip away from the front to give it to the back.
Right, but I don't get all of what I take away. I lose some in that process.
I don't know that that's true, but I've never thought about it in those terms before. That might be an overcomplication of what's going on.
Nick, do you know who you're talking to? An overcomplication from me?
So let's keep it simple.
Okay, we're keeping it simple.
Let's keep it simple.
All right.
Who cares how many units of grip there are?
Right.
All I care about is, do we have as much as we can get out of the tire, and does the car feel good?
Mm-hmm.
That's really what matters.
Right.
So if the tires are telling us they've got all the grip that we can get, but the car is an oversteering mess, then we can move some of that grip from the front to the back by increasing the front springs or the front bar, or by decreasing the rear springs or the rear bar.
Okay.
Now, notice I didn't say anything about taking camber away from the front.
Right.
Because we've worked so hard to gain as much grip as possible by perfecting the camber. Now, if you take camber away from the front, will the balance get better? Probably. Because
you're giving up grip.
You're giving up front grip, but you're not gaining any rear grip. Rather than move the grip, you've just reduced the grip. Okay. So it's better to move it than to reduce it. So leave the camber alone, add some front spring or bar. Let's just say we're adding, and then go drive it again. And the grip will have moved from the front to back. You will not have lost any. You'll just put it where it was needed, and the balance will be more in line with what you want. And maybe it's perfect. Maybe like, ooh, that was really good. Let me do a little bit more. Or maybe it's like, ooh, that was too much. Now the car's understeering like crazy, and then you meet yourself in the middle. If you did a 100-pound change, try a 50-pound change.
Okay, and that would be to either change the spring or the bar.
Correct. Yeah. Now shocks are kind of the elephant in the room, because that's what almost everybody goes to first, is to adjust the shocks.
Well, there's those buttons and you spin them.
Yes.
That looks cool, man. By the way, just FYI, cool.
They're cool. Shocks are cool. I used to build shocks. Shocks are fun, but shocks have a job.
Yep.
And it's a different job from the spring.
It's speed based, right?
Correct. So there's a lot of misunderstanding and misinformation about what the shocks are actually doing. Like I always used to hear that the easiest way to control a linear spring is with a linear shock. But the two have no correlation. A linear shock means a completely different thing from a linear spring. So the job of the spring is to support the weight of the car and create the overall stiffness of the suspension. How quickly, I shouldn't say quickly, how stiff is it? How much does it resist compression? And how much does it resist body roll? That's spring. The job of the shock is to control the motions of the suspension. So to prevent it from bouncing and oscillating.
So like a damped harmonic.
That's exactly what it is.
Vibration.
That's exactly what it is. If you had no shocks whatsoever, the car is going down the road and hits a bump, it's going to bounce up and down and up and down and up and down forever.
I've seen that.
Springs are perfect.
I've seen that on the road.
Yeah, 88 Cutlass Supreme, right?
Pretty much. Every single one.
Yep. So even if your spring rates are quote unquote perfect, if with no shock absorber, it's going to oscillate. It's going to bounce up and down. So the springs create the handling balance. The shocks control the behavior of the spring. And that might piss some people off to say that, because of course the shocks also do affect the handling balance, but that's not their primary job. Their primary job is to do what you call the timing. So how quickly does it compress? How quickly does it rebound? And that will control those oscillations. So springs first, springs and bars, because bars are springs, to create the balance of the car, and then tune the shocks to taste.
Okay. So you've brought up what scares me, tuning the shock. So I have unadjustable shocks in some cars. I have single adjustable shocks in other cars. And I am scared to death of anything more than a single adjustable shock, because I figure the more knobs I have to turn, the more I'm going to screw it up.
And that is what most people end up doing with more knobs. So you're not alone.
But at least I knew it and I didn't spend the money yet.
Yeah.
Yet.
So a dual adjustable shock is awesome if you have somebody who can make the right adjustments to the knobs. So let's talk about a single adjustable first. So a single adjustable shock doesn't really change the balance of the car, asterisk, because it does, but kind of for a weird reason. So what a single adjustable shock lets you do is match the amount of damping force to your spring. So let's say you put in 100-pound stiffer springs.
Yeah.
Single adjustable shock allows you to match the damping force to what that spring wants. Because generally speaking, a stiffer spring will need a little bit more shock force to manage that motion.
So does that mean it's track independent once it's balanced?
No, not entirely, because a bouncy track will generally want a softer setup. So I put an asterisk up there, right? Because it's never quite that cut and dry. So if you are on a glass smooth track, then you can get away with a stiffer shock, and it's not going to hinder you really. If you take that same setup and you go to a bouncy, if you go to Sebring, you're going to rattle your teeth out, and the car is not going to like it. The tires are not going to like it. They're going to bounce over the surface and not create much grip.
Yep.
So if you're going to Sebring, you're probably going to be softening your suspension up.
Okay.
Now, you can use a single adjustable shock to change the balance of the car, but it's sort of a Band-Aid situation. It's not really what it's meant to do. So for instance, if you've got a car that's understeering, you can crank up your rear shocks and it will probably alleviate some of that understeer. But it's doing that by taking grip away from the back.
That's a no-no.
Yeah. Well, I mean, if that's what you got, then that's what you got.
Yeah, but that's not the first choice, right?
Correct. That's using the handle of a screwdriver to hammer in a nail. We've all done it.
No, never.
Not Bill. Bill's never done that.
Dude, if there's one thing I have in the garage, I've got lots of hammers. I don't have any problem.
Yeah. So let's just briefly, let's go back to alignment as well. There are some like autocross classes specifically, like stock classes, where you're not allowed to change anything. So maybe all you can possibly do is your alignment. So maybe in that very specific case, taking some camber away is the right answer, because even though you are taking away grip, you are technically improving your balance, which might allow you to drive the car faster.
But that's only because you have no other choice, right?
Exactly.
Okay. So what about, well, we're staying with the single adjustable and the non-adjustable. What about these guys who adjust or dial in the valve thing? I have no idea what that means. It sounds cool though.
Okay, so real quick crash course on what's inside of a shock. We'll talk about a monotube because they're easy to conceptualize. So you've got a cylinder, and inside that cylinder, you have a whole bunch of oil, and you've got a piston. And the piston's got holes in it. So if the piston's going to move up and down, the oil has to flow through those holes.
Okay.
If the holes are really big, it's very easy for that piston to move up and down. If the holes are really small, it's much more difficult to move up and down because the oil is thick and it's hard to get it to flow through those little holes.
Okay.
So did that make sense?
Yep. I'm with you. I'm waiting for
Okay,
you're going to tell me I did something wrong though, so I'm just waiting.
No.
Not yet?
So that's the basic of what a shock is doing.
Okay.
It's difficult to press. And the faster you try to press it, the more oil you're trying to shove through those little holes. So it's harder to press. And that's why if you move a shock very slowly, it's not difficult at all. But if you try to push really hard, it resists a lot because you're trying to flow all that oil through those little tiny holes.
It's like silly putty.
Yeah. Well, and shock oil comes in different viscosities as well. You can have the really thin stuff, or you can have the really silly putty thick stuff, and that does the same thing as changing the size of the hole, as it makes it easier or more difficult to flow.
Okay.
So that's basically what's going on inside a shock. There's a, as with anything, there's the rabbit hole goes deep, but for our purposes of this conversation, that's all you really need to know.
That's a separate episode.
Yeah, exactly. So what those people are doing when they're changing the valving inside of a shock is they're changing how easy it is for the oil to flow. And it flows both directions. So for compression, it's going through a particular set of holes. And for rebound, it's going through a different set of holes. And you can have those holes be larger or smaller.
Sneaky guys.
Yes, exactly. Well, all shocks do that. So a shock, I'm not going to say always, but usually is going to have significantly more rebound force than compression. So it's easy to push it down, hard to pull it back up.
Okay.
I'm talking about road racing specifically.
Mm-hmm.
And an easy way to think about why is because the spring is creating compression force, so you don't need the additional compression force from the shock.
Okay.
But the spring is pushing back and trying to rebound, so you need all that extra rebound force in the shock to counteract what the spring is doing.
Okay.
Because you don't have a spring going the other direction. It's only going in one direction.
Mm-mm.
Yeah, so what they're doing is they're changing the size of those holes. So when somebody's going in and changing the valving inside their non-adjustable or adjustable shock, what they're doing is they're changing the size of those holes, basically, making it easier or harder for the oil to flow through, both on compression and on rebound. And maybe they're probably changing those independently of each other. And so then you can tune your shock to whatever spring rate and whatever conditions that you want. So when you turn the knob on a shock, you're doing exactly the same thing. You're making it easier or harder for the oil to flow through. Okay. So when they revalve a shock, they're doing the same thing as you turning the knob. But when you revalve the shock, you can get much more detailed with what part of the graph, I'll call it, what part of the graph, the shock dyno that you're actually changing. Because, of course, as with all things, it's pretty complicated and there's more facets to it. So you can change the low speed behavior. So when you're just pushing on it really slowly, 1 inch per second, 2 inch per second, half an inch per second of travel. And you can change that independently of high speed, 10 inches per second when you hit a bump really hard. So low speed on a shock, that's what the driver's feeling generally as this car feels really stable or this car is kind of wallowy. That's low speed control. When you're turning the wheel and leaning the car, that's the low speed of the shock. High speed is when you're hitting bumps or curves. Boom. And you can change those independently of each other.
Okay.
And the reason I bring that up is because the knob on your shock is mostly changing the low speed rebound.
Low speed rebound. Okay.
However,
so that's slow coming up.
Yes. Okay. And this is the last complication I'll add to this. When you add...
You lie.
I know. When you stiffen up your low speed, the rest of the curve is also affected. So stiffening up the low speed will also stiffen up the mid speed and the high speed.
So it's like a course adjustment.
Yes, exactly. It's a course adjustment. So the problem with that is if you start cranking up the knob on your shock, yes, the car will probably feel more accurate, more stable. But when you hit those bumps, look out. It's going to be rough because you dramatically increase the high speed as well, even though you didn't really want to.
Yeah, I did that at Mid-Ohio once. It was not fun.
Yeah, so describe it. What did it feel like?
Somebody shot me in my bottom somewhere. It was the club course, and that's got the little chicane on the, I guess that would be the front straight, I guess. I don't know. It's got the chicane going in the keyhole. And I was taking a class, and the instructor said, try to clip the outside right rumble strip, but don't go too far because the racers had dug a nice big hole. So what did I do? I went too far and I hit that hole, and boy, did I hit that hole.
Oh, wow.
Only did it once. Only once. It was painful. I was like, I just broke my car or my tire or my butt. I'm not sure. One of them is broken.
Maybe all three.
It could be all three. Yeah.
Well, it brings up an interesting point. If you were building an off-road car, you would have much softer, more supple suspension for that exact reason. And you would also need to be higher, because if the suspension is softer, it's going to bottom out easier.
Right.
So you soften it up and you lift it up.
So I was trying to figure out how to put this in, and you just opened it up for me. What about suspension travel? Like, is this a good spot or is this a bad spot?
No, this is great. I don't think we need to go any deeper on shocks, because we will be here until about tomorrow or the week after.
Welcome to episode 65 of the
That's not good for me right at this moment.
Baby steps.
She needs it in small bites right now. She's like, oh my God, my head is swimming.
No, I feel myself sliding down.
No, don't slide.
Because I'm fading.
No worries. Okay, so suspension travel, I always think you want as much as you can get.
Maybe.
It depends. It's like talking to Ross Bentley again. It depends.
So you want as much as the car is going to use, and anything past that point is just a waste.
Sure.
So if you've got 6 inches of travel, but the car only moves 2 inches, then you've wasted your effort building all this extra travel into the car.
Okay.
What you do want is you want enough travel. Let's talk about compression first, because there's compression travel and rebound travel. And really they're the same thing. It's just the suspension moves up and down. And remember, we talked about our static point. So that's where the car just sits when it's just in the parking lot. If it compresses, that's compression travel. And if it rebounds, that's rebound travel. So it's just the upper and lower of the same thing.
So compression is when the suspension gets tighter to the body of the car, and
right.
And what's the other one?
Rebound.
Rebound is when the tire has to go away from the body.
Yeah, okay. Also called droop.
I've heard that one.
Yeah. Now, and it should be noted that they picked the same words as the shock absorbers with compression and rebound, but now we're talking about travel instead of forces, because they wanted to make it more complicated on purpose to make sure Vicky's head explodes.
It's working really well.
It is right now. So right, I'll have to go back and listen to this a couple times as I'm working on suspension and start to understand it.
And we can actually separate them out. So if we're talking about the valving and the shock, we've got compression and rebound. There are other words that we can use for travel, and they are bump and droop. So let's use bump and droop and make it a little bit simpler. So bump is when the suspension compresses and the wheels go up inside the fenders. Droop is when you take off from a jump and the tires droop down as far as they'll go.
Right.
Bump and droop. So when we're talking about bump travel, you want it to go as far as possible without hitting anything. Remember, we talked earlier about taking the spring out and running the suspension through its travel.
Yep.
And one of the things you should do there is see what hits first. So in a production-based car, it's really common, like a Miata, for instance. Miatas have very little bump room before something hits something. And usually it's the tire will hit the inside of the fender.
Yep, the liner.
Yeah, the liner. Or if you're taking the liner out, it can actually hit the metal part.
Yeah.
So that's a good point. If you take the liner out, you gain a little bit of bump travel, which is good, because you allow the suspension to move further. If you run out of travel, we find
the liners to be self-clearancing. I'm just saying.
Yeah, a wheel and tire is kind of like a lathe, right? You got 4 lathes built into your car.
It's exactly. It's like, and it's bespoke then, so it's got to be more valuable. And it's lighter. It's awesome. So if you go up and the tire touches the inside of the fender, you have run out of travel, and then you have to start introducing some compromises. The best thing to do in a perfect world would be to cut out whatever piece of metal it was hitting and allow it to travel further. That would be the best thing, because then you can just let it continue to move freely and the suspension will do its job. But
typically you can't do that because you're going to compromise the structural integrity of the car, and also it's illegal in basically every racing series. You can't touch the unibody of the car. So what do you do if you can't do that? You can raise the car up.
No,
that's a simple one.
That doesn't look cool though.
It doesn't look cool at all. So we're not going to do that.
Nope.
No, so that is, but it is a consideration we should talk about. So if you raise the car up, you will gain more compression travel, but you will lose rebound travel. So I know, Bill, you like to talk about numbers. Let's apply a unit
I like numbers. I can do it. I can bust out Excel if we need it. Just let me know.
We shouldn't need it. This one's simple.
All right.
You've got 100 units of travel.
Mm-hmm.
You can use it for bump or you can use it for droop. And if the car starts right at 50, you've got 50 for bump, back to 0, 50 for droop.
Okay.
Back to 0. 0 is the wrong word. Back to 50. And then you got the
center.
other 50 for droop. You know what I mean?
We'll go with center.
Center, yeah. So if you raise the car up, suddenly you're not starting at 50, you're starting at 30.
Mm-hmm.
And then you got 70 available for compression and only 30 available for droop. And maybe that's okay. Maybe that's okay for your application. Maybe it's not. It kind of depends. But that's probably not going to be the answer unless you've got your car slammed to the ground and it was wrong anyway.
Mm-hmm.
So let's say you like where your ride height is. You don't want to change it. What else can you do? And again, we're talking about compromises here. It's never going to be perfect. So what you'll have to do is prevent the tire from contacting. So you'll have to stop it from traveling before it can get to that point. And you can do that in a couple of ways. The first way is a bump stop.
Knew that one. I was there. I was on it.
So you want the bump stop to be long enough that it hits the bump stop just a tiny bit before the tire hits the fender.
But don't the bump stops compress a little bit? So
They do.
Okay.
Yeah. So you have to factor that in. Let's say it's a couple millimeters. So a couple millimeters before the tire touches, and you'll have to test it to figure out exactly. You can lift it up by that corner and compress that bump stop a little bit and make sure you've got enough room.
Okay.
So the drawback here is that now if you do compress suspension that far, let's say you hit a curb, when it does hit that bump stop, you're going to feel it.
Mm-hmm.
It's going to crash all that extra energy into the chassis of the car, and it's going to potentially upset the car. It's not good for grip.
Nope.
So the other option is you can stiffen your suspension, which essentially limits the travel because the spring is going to reduce the amount that it compresses with that same curb hit.
More force to compress the spring.
It would require more force to compress the spring, yeah. But that's also a compromise because now you are increasing your spring rates and maybe making the car a little bit harder to drive. Maybe you're increasing the spring rates past what they should be for the tire that you're running, because the grippier your tire is, the stiffer your springs will be, generally speaking.
Okay.
The less grippy, so like an RS4, an Endurance 200 tire like that, you will want a relatively soft spring.
Mm-hmm.
Maybe this should have been the first thing I led with, but a softer spring creates more mechanical grip.
Okay.
But just like everything else, it's a compromise. You want to have enough spring rate to make the car feel good, but not so much spring rate that you are reducing your grip. There's a happy medium.
So this is the point in the podcast where we have a public service announcement. This is a public service announcement for the National Emergency Broadcast System, where that the stiffest spring you can possibly buy is not the best spring for your race car.
Unless it's the back end of a fit, maybe.
Unless it's the back end of a fit, then you just put in a solid steel block and call it good, because you need the weight back there anyway.
Bill's words, not mine.
Okay. Very well. Okay.
Yeah.
Because everybody seems to like stiff cars. It's like, why?
Well, why indeed? So, and there are reasons to stiffen up a car, because it will make the car, quote unquote, racier, which is important if you are dicing with traffic. You want the car to be very maneuverable, very precise. So a stiff spring will help. You also want to counteract too much body roll. And those two things go hand in hand. But as we talked about earlier, more body roll means more camber change.
Right.
and other things as well. It might send your roll center through the ground and dramatically change the handling characteristics of the car. You don't want it to go too far.
Right.
How far is too far? It all depends on the car.
Can't be much further than my ND Miata was on stock springs. And
oh my gosh, they're so floppy.
It's like, woo! I felt like I was listing more than turning.
We always used to call that door surfing.
Yep. I can see why. I can see why.
Yeah, so there's a happy medium, and I can't, just say you want this spring rate, because it's totally different depending on the car you're driving, how much it weighs, what kind of tire you've got, what tracks you're at. There's too many factors to give
front wheel drive, rear wheel drive, blah blah blah.
Yeah. It's way too in depth, but that's where you have to start doing testing, and the more you know about what you're after, the more educated of a guess you can do to start with, and then fine tune from there.
Okay.
But you can. The way I like to set up suspension in a car is I'll start with the bounce frequency, which is, how quickly with that spring rate does the chassis move up and down when you hit a bump. And there are online calculators where you can look at this. If you Google suspension bounce frequency, there's a ton of information about this. And it's beyond the scope of what we're talking about right now. But if you've got a basic production-based car with no aerodynamics, you're going to want to be within a certain range of your bounce frequency. Then if you start to add downforce, that number is going to go up. And then if you're talking about like formula cars, it's going to go up more and more and more. So you can figure out kind of a range where your car's probably going to be happy, and start within that range and then adjust to taste from there.
Okay. So I think we've gotten to the point where we're almost going to help somebody dial in a car.
Almost. We're so close.
We're so close. But I think that's going to be another episode.
I think you're right.
I think we will. So, Nick, we've had much fun. We're going to get to part 3, where we are able to get into how to adjust your car and how to take all this stuff that we now know and stuff that Vicky's listened to this podcast 5 times. And we're going to start adjusting the car. But if people can't wait and they want to see and hear from you, perhaps even take advantage of some of the services that you offer, how would they find you?
The easiest way to find me. I was going to try to make a joke, but I couldn't think of it fast enough. No, go to fastsideways.com.
The joke was fast sideways. The joke was, it went fast sideways.
I am the joke.
You are. You are.
Yeah, so fastsideways.com is a website. That's for their driving school, car control clinic. There's nothing on that website about chassis setup, but you can always just send me an email. I love talking about this stuff. I love helping people out. And we've got some upcoming courses.
Do we?
We do. Willow Springs on the 30th of this month of April. And then later this year, we've got Thunder Hill on July 16th. And then again on November 5th, also Thunder Hill. And then, of course, sim coaching any day of the week, anytime you like. Sim coaching and video review.
Weather's always nice in Sims.
Yes, it is. My favorite part about that is you can do it on a Wednesday night in your pajamas.
You can indeed. You know what I really want? I want iRacing to have a rain setting. That's what I want.
Oh man, you're about to open a can of worms here.
Well, I know iRacing is your favorite, and it's the one that you love the most, and it's it's a marriage that you love, because I've watched your videos, so I know what I'm saying, and it's driving you absolutely crazy right now.
My head's about to explode too, Dickie.
I know.
Yeah.
I know. This is the fun of
you can do rain with Assetto Corsa. You can do rain with Project Cars too. So there are options out there other than with iRacing, and then you can practice your car control in the wet. Again, on a Wednesday night in your pajamas.
Oh, I have a question then. Since you would know this answer, and I have been puzzled about this. Does it vary from track to track? Like, is Mid-Ohio really Mid-Ohio, or is it kind of a blanket that covers all tracks?
Ooh, that's an excellent question. I don't actually know, but you know what? Mid-Ohio is my next race in WRL. In fact, that's this coming weekend.
How fun.
So by the time this comes out, it'll already be done. So hopefully it went well, and hopefully this aged poorly. But so I'm going to be jumping on the sim and testing it out. But since you brought that up, I will try it. I'll turn on the rain and I'll see. Now, what was the corner? You said it was like a certain
any
section
of them
that was really bad?
No, it doesn't matter. It does not matter.
Okay.
Yeah, it does not matter. Let's put it this way. You know how the way that I think about it, and you're much better at this than I am. But I'm going to tell you what I do in my mind to simplify. My model is, if the line is the line when it's dry, got it, no problem. As it gets wet, I start moving car widths or half car widths off of the line. And as it gets really wet, I'm like a full car length or maybe 2 car lengths. Mid Ohio, it's like the next zip code. It's like if I am supposed to be on the left-hand side, I am all the way track right. All the way. And I still don't have enough. So that's what I do. I don't know if it's right, but that's what I do.
That's kind of how it felt at the 25 in the rain as well. But it's sketchy because then if you overcook it even slightly, you've got no pavement.
No margin for error. No margin whatsoever. None whatsoever. Nope. Okay. So I will do Mid-Ohio gifts for you after the podcast, but thank you for coming on.
Thank you very much for having me again.
Thank you.
Vicki, I hope your head is still where it's supposed to be.
Yeah, I haven't worked enough on suspension to kind of grasp it, but that's going to be one of the areas out in electrical. So then I'll be able to better understand the more I'm dealing with it.
Well, you'll definitely have to get somebody else on for electrical because
that's not it.
Oh boy.
Not going to do electrical part 1 with us?
Nope. No, thank you. I'll listen to it. I'm happy to learn. But yeah, I will not help anybody there. I'll just that will result in lots of cars burned to the ground.
Yeah. I'm learning though.
Grounds are important. Yeah. I think I think she's progressed quite well mechanically, but I don't think she's got the part switching and the assembly disassembly done, but I'm not sure she has the understanding of what the parts actually do, and that's the suspension. She's changed suspensions a bunch of times.
Yeah.
But we'll get there. Inch by inch every day.
Inch by inch.
Episode by episode.
Episode by episode.
The end is near.
Phone a friend by phone a friend.
I can see the end of this probably 3-part series of Suspension 101. I'm going to have to get much better at asking questions for a 201 level, but I think we might get the 101 on the next episode, and it could be fun.
Does that mean this was 50?
I don't know.
I think this was 101. Last one was 50. This is 101. We'll do 201.
Yeah, we'll do like 10. Maybe it'll be 102. We'll see. We'll figure it out. Thank you, Dick.
All right. Thanks again, Bill and Dickie.
Thank you.